So this video lesson is on balancing chemical equations and how to do it. This is the main conduit for gathering and disseminating the technical information that you need to develop the skill set to be able to balance chemical equations. I'm going to spend a little bit of time on it in class, but this is the main conduit I'm going to present it in. We'll have some practice the next time you come in, but after that we're going to move on. We balance chemical equations to abide by the law of conservation of mass, which says matter cannot be created or destroyed. When we balance chemical equations, we're assuring that the number of moles of atoms for each element must be the same for products and reactants. Now, you don't know exactly what a mole is yet, but think of a mole as a unit of measure of atoms. Think of it like cups or grams or pints or things like that, right? So we're going to make sure that we have the same number of atoms and type on the reactant side as we do for the product side. Now, how can we manipulate the number of atoms on each side? We can change the coefficients in front of each formula. What we'll never do is change the subscript, as this will change the chemical identity of the compound. So for example, H2O, I'm never going to change H2O into like H3O because now H3O is no longer H2O, it's a different compound. So again, what is balancing a chemical equation and why do we need to do it? The what is, we're going to make the amounts, mass and the atom number of the reactants equal to the products. So in other words, every atom on the reactant side, type and number, has to be equal on the product side. And why do we do this? So we don't violate the law of conservation of mass. Again, we cannot create or destroy matter doing any chemical or physical process. And another reason why we do it is we're going to be able to make predictions on amounts necessary to drive a reaction given other amounts of reactants and products. So in other words, if I said to you, if I have 3 cups of flour and here is the recipe for making cookies, how many cookies can I make? And that basically is the same concept that we're doing with a balanced equation. Okay, so here is a little pictorial representation of the concept of balancing a chemical equation. So think of a balance as a seesaw or teeter-totter or whatever you want to call them. And on this side of the chemical equation, we have 2 compounds. We have A2 and B2, right? So there's 2 A's, so and they're linked together, so it's kind of like a diatomic element. So this could be representing like O2, Cl2, N2, and the same thing here. Notice that this atom is smaller than this atom, right? So there's a difference in mass. And then when we mix these 2 together and do a reaction, we make new materials. We make AB and AB. Notice that the number of atoms, A, there are 2, is the same on each side. And the number of atoms of B on each side is 2, right? And then the other thing that we have to be concerned with is that we have the mass on this side has to equal the mass on this side, right? So when we have a balanced equation, the mass is equal and the number of atoms of each type is equal. Now here's a key concept to take away. If we balance the atom number and type for each element, so which is represented by this yellow box here, then by definition we always will get this result. The masses will always be the same because we have the same number of atoms, their size, and we have that on both sides, so the mass will automatically fall out of balancing the number and type of each atom. So real quick, what are the parts of a chemical equation that we're going to be dealing with when we do balancing equations? The first thing we're going to talk about are these coefficients. Now, what is a coefficient? A coefficient is the number that you're going to be allowed to change in front of a chemical symbol or a chemical formula. So this is my chemical symbol for aluminum. This is my chemical symbol for oxygen. This is my formula for aluminum oxide. It says here that the coefficient represents how many of these things. So we have 4 aluminums, 3 O2s, and 2 Al2O3s. The subscripts, which are represented by blue here, are the number of atoms in that particular species. So we have 2 oxygen atoms in a oxygen molecule. We have 2 aluminum atoms in a aluminum oxide particle. And we have 3 oxygen atoms in that same aluminum oxide particle. The elemental symbols are what we find in the periodic table. So Al is aluminum, O is oxygen, and the same thing here. So remember, the reactants are always on the left side. These are my reactants, and these are my products. So when we go to balancing the equation, the only thing that we're going to be changing are the red numbers. And I'll explain that in the next slide. Okay, so here's the quick tutorial or walkthrough how to do this. So what we're going to do is we're going to do an initial atom count for all the elements on the reactants and product side. We're going to change coefficients until the number of atoms of the elements is the same in reactants and products. There's a couple of hints here and keys. I'm going to go through those as we do them. And under no circumstance are we ever going to change the subscript in a compound to help us balance a chemical equation. By changing the subscript, we are now changing the formula and the composition of that material, and we cannot do that. Okay, so we're going to start the demonstration of this right now. So the first thing I always do is I'm going to do my initial atom count for both my reactants and products. And what I like to do is to make sure that I'm counting on the correct side, I draw a line right down the arrow, right? And then I just list each element as they're listed here. So there's element of N, and then there's an element of H. We don't list the coefficients yet, just the elemental symbol for each element that's in the reaction and product, right? Now we go back and we go do the count. So we're going to count. So we're going to say we have 2 nitrogens, and look with my H, I have 2 of those. So let's go write that real quick. We have 2 and 2. And I do the same thing on this side. And I see I only have 1 nitrogen, but I have 3 hydrogens. So we just quickly write that. And so far, so good. So I've completed step 1. Now, I'm going to do the same thing on step 2, except now I'm going to manipulate the number of atoms on each side by changing coefficients. So I'm going to add coefficients or change coefficients in front of each reactant and or product until I can balance my equation. So we start out with N equals 2, H equals 2, N equals 1, H equals 3. Now you can do this. You can pick whatever one you want to balance first. There's no rhyme or reason in which one you want to pick. So we're going to pick the nitrogen because it looks like it's the easiest one to pick. So we're going to say, okay, so on this side of the balanced equation, I already have 2, but I only have 1 here. So I have to multiply the thing that has the nitrogen in it by some number to get me 2. And so that is a coefficient. So we're going to put a 2 right here because now it's 2 times N, which is 1. There was 1 in here, so now there's 2 of those. And there are 6. 2 times 3 is 6 hydrogens. So we're going to change this to 6, and this equals 2. So far what have I done? I'm comparing the nitrogens, and I've done that. I've balanced the nitrogens. Where up here, the nitrogens were not balanced, neither were the hydrogens. But so now far I've made one step further, closer to the end, and I've balanced the nitrogens. In the meantime, I've changed the number of hydrogens, but that's okay. We're going to go back now and balance that. So let's go back and try to balance that. So what number? So I'm going to look for the thing that has the hydrogens in it, and there it is. And I need 6 of these now instead of 2. So what number can I put here that if I multiply it by 2 will give me 6? And hopefully you can see that that number is 3. All right? And when I do that, it's going to be 3 times 2 H's, or 3 H2's, so that's 6 H's total. So we're going to change this now to 6. And does that balance with the hydrogens here? It does. So that's balanced. So my final balance formula is the following. 1 N2, sorry, there's a 1 here. We never write it. Remember that. 3 H2's. If I react 1 N2 add a molecule with 3 H2 molecules, I get 2 NH3 molecules. And there you go. Or 1 mole of N2 plus 3 moles of H2 gives me 2 moles of NH3. So we've balanced it. Okay, so we're going to do the exact same thing on this one, except I'm going to give you some pointers to help you understand a little bit, some shortcuts or some things to look for when you balance equations. So we're going to do the exact same thing we did before. I draw a line down the middle, write down the separating the reactants from the products, and I always list the reactants as they come in the reactant side as they're listed. So it's Al's listed first, so that's why I put it here first, and then oxygen. I don't list O2, it's just oxygen. And then whatever I listed on this side in the order, I list the same on this side in the order. Even though the order may have changed as you do the reaction. It's easier to compare this way than if you have to go find ALO down here or whatever. So I always just, whatever list I have here, I make the same exact list on this side. All right, so now we're going to do a quick count. So we have 1 aluminum, and we have 2 oxygen. And you can see where I got those. There's 1, there's no subscript, so it's 1, and then here's my 2. On this side, I have 2 aluminums and 3 oxygen. All right, so there's my initial count. So we're going to repeat that down here real quick, and then I'm going to show you some tricks. And here we go. Now, the trick is, since the aluminum is all by itself, it's not a diatomic element, it's not in a compound, it's all by itself, we're going to save the aluminum to be last, because we can quickly change this thing to be whatever we want for this side. So there's 1, we can put a 2, we can put a 3, we can change whatever we want. Every time we put a number here, we not only change this, we're going to have to change this too, right? So let's go through and do the oxygen first. Now here's the second tip. Notice we have a 2 here and a 3 here, and it's going to be hard to balance with a 2 and a 3, right? It's not like 2 and 4 or 2 and 6. But what is the common factor between 2 and 3? In other words, what can I multiply? What does this go into and this go into that's common? That's called the common factor. And you would see, an easy way to get that is just to multiply 2 times 3, and you can see they both go into 6. So we're going to try to make this side be 6. So how do we do that? We're going to put a 2 here. So because 2 times 3 gives me 6. And again, we want to make sure on this side we get 6, because they have to be the same. And so what are we going to put over here in this box here, or this coefficient here, to get times 2 to give me 6? And you would see, hopefully, that that's going to be 3. All right? So have we balanced the oxygens? We have. But we've changed also the aluminum. So let's go back and change the aluminum amounts. 2 times 2 aluminums, 2 times 2 aluminums equals, that's 4 aluminums. And so let's do that. We're going to make that 4 now. Now here's where it's easy now, because over here the aluminum is 1. And what can we put in the front of aluminum to make it 4? Well, there's the answer, is right there. It's going to be 4. And I haven't changed anything else in the equation, just because I haven't changed anything over here, because the aluminum stands all by itself. So we did that to last, and just to make sure that we've done it, we're going to make this a 4, and so therefore this checks out. So those are two quick tips that I gave you. Common factor, save the lone elements for last. Okay, here's the last demonstration. I'm going to show you a little trick that we have when we use polyatomic ions. And here's a polyatomic ion right here, and here's another one here. So since the polyatomic ion on the reactant side is in the same structure as the product side, in other words, it doesn't change its composition, it doesn't break apart, we're going to keep that as one entity. So when we do our atom count, we're just going to say it's an SO4 entity. So we have calcium, SO4, Al, and Cl. And then we just list them the same way on this side. And we don't change the order because it's hard to change the order. And all right, so now what we're going to do is just do our atom count again. So we have 1, we have 1, we have 1, and we have 3. Here we have 1, we have 3, we have 2, and we have 2. So we have a bunch of things that we're going to have to balance, all right? Now, there's no rhyme or reason of what you have to start first, all right? You can say, well, let's start with the SO4s, and that would be fine. Or you could say, let's start with the chlorines, and that would be fine too. Whatever you want to do. So I'm going to start with the aluminums, because there's a reason why I'm going to start with the aluminums. I can notice here that I have a 2 for the chlorines. Sorry. A 2 right here for my chlorines and my 3 here for my chlorines. And I showed you before that when you have an odd even thing for the same element, you're going to look for the factor. And I think I can get there by putting, and I have to worry about the aluminum too. So let's just try to balance the chlorines first. All right, so let's do that. And so on this side, I want to get to 6. And in order to do that, I have to put a 3 here. Because basically what I'm saying is 3 times 2 equals 6. All right? So again, let me just do that. 3 times 2 equals 6 chlorines. And I want to get, therefore, I want to get 6 chlorines over here. And in order to do that, I have to put a 3 here. Excuse me, a 2. Why don't we make those the same colors we did before, just to show you. Okay? Now when I do my atom count, I'm going to say, wow, I changed, not only did I change the chlorine count, I changed the aluminum count to 2 on this side, and I did nothing to the aluminum count on this side because it's in a separate thing, but I did change the calcium to 3. So now we've got a couple of things already balanced. We've got this balanced, and we've got this balanced, all right? And we have a factor here of 3. Notice we have a 3, 3, and a 1, 1. So hopefully these are in the same formula. That would be great. So let's look at that. If we put a 3 in front of my calcium to balance my calcium, that becomes a 3, but not only does that become a 3, the SO4 becomes a 3 because we have 3 SO4s. And so when we do that, that's what we get. And let's make sure we're balanced. We have 3 and 3, and 3 and 3, and we are balanced. So at the end of the day, we are balanced. And my final balanced chemical equation, 3 CaSO4s, calcium sulfates, plus 2 aluminum chlorides, yields aluminum sulfate and 3 calcium chlorides. And there you go. All right, so the last thing that you're going to do is you're going to use these equations and you're going to balance them on your own. And I will publish the answer key a little bit later on after you watch the video. So this is what you're going to do for your homework. You can stop the video, copy these down, and then balance using the techniques I just showed you. You can rewind the video, go back to the beginning to see how we did that, right? And that'll be your tutorial for today. Let me know if you have any questions. You can either contact me offline or ask questions in class.